Hi, welcome back everybody. Today we have a difficult physics question actually from the digital SAT math. It's a wordy problem, a huge paragraph. It's physics, it's not really math. There's a lot of things to be intimidated about it, but these question types are so common that they become some of the easiest question types because you're going to see them over and over again. So if you're kind of new to studying for the SAT, these are going to be very intimidating, but once you become more advanced, they become some of the easiest questions on the test. So let's go ahead and take a look at this example. It says a fetch launcher machine launches a silicon dog toy from ground level. The toy reaches a maximum height of 15.68 feet above the ground at 2.8 seconds and hits the ground at 5.6 seconds. Which equation represents the height above ground h in feet of the dog toy t seconds after its launch? So there's really two main ways that we could solve this. The fastest way is actually to just know the math, which is to know the vertex form. So this form right here is something we call vertex form of a parabola. That's as opposed to the standard form, which you guys have all seen. So ax squared plus bx plus c is like the standard form of a parabola. This right here is called the vertex form. And this is where hk is equal to the xy of the vertex. And for those who are not in the know, the vertex is just like, let's say if we had an upside down parabola, the vertex would be the maximum. If we had a U-shaped parabola, the vertex would be the minimum there. And so kind of knowing that the h is kind of our y and the t is basically our x, right? I can immediately see that D is going to be the correct answer. And the reason why is that here I would have my x value with time. So 2.8 seconds, and then here I'd have my y value of the height, right? And so this right here would be my h and my k, so represents the vertex then. The x of the vertex and then the y of the vertex. Now, let's say you didn't have the vertex formula memorized and you just weren't 100% sure, then we could also, of course, go to Desmos. And if we model functions like this in Desmos, let's say if I looked at the first answer choice and I did negative x squared plus 5.2.8, I can see here that I don't really have the maximum height that I was looking for, especially if I kind of realize that the y-axis is the height and the x-axis is the time, right? But if I went ahead and plugged in an answer choice like D, let's say negative 2 times x minus 2.8 squared plus 15.5 or 0.68. Here I can see that it launches from the ground here. It's like the starting point. It goes up to its maximum height of 15.68 feet at 2.8 seconds because again my x-axis is seconds and my y-axis is the height. And yeah, so this is looking really good to go. It's the only answer choice that would have fit this scenario that they described. So definitely don't be afraid to just either double check on Desmos or solve via Desmos if that's what you prefer. Now, if you like this content, you found it helpful, and you want to know more about the digital SAT, be sure to like and subscribe, and we'll look forward to seeing you in the next video. Hope you have a great day.